Hello students, previous class we are discussing on chapter sets. Previous class we are discussing the operations on sets. First we discussed union operations. What is union operation? Then examples, Venn diagram. After that some properties of union operations we discussed. Today we will discuss another operation on set, that is intersection of sets. Let A and B be any two sets. Then intersection of these two sets A and B is denoted by A. This is the symbol for intersection. This symbol A intersection B. We will read A intersection B. This symbol we are using for intersection and is defined as A intersection B is the set of all those elements which are common to both A and B. Means A intersection B is also a set, and which type of elements it contains? The elements which are common to both A and B. That is the intersection of A and B. Mathematically we can write like this. Mathematically A intersection B is a set of all elements X such that X belongs to A and X belongs to B. Then Venn diagram for the intersection of two sets. So previously when we are discussing on union operations, also we discussed the Venn diagram of union of two sets. Similarly here also we can draw the Venn diagram. Yes, suppose U is our universal set. So U is represented by a rectangle and A be any set, B be another set, which is both A and B are subset of U. Then A intersection B is the elements which are common to both A and B. So means these elements are common to both set A and set B. So the setted portion is our A intersection B. Here A and B are intersecting each other. So in this case we are finding the Venn diagram like this. Suppose if A and B are not intersecting each other, means this is our universal set and this is our A set which is a subset of U. This is B set which is also a subset of U. So here both are not intersecting. So in this case we cannot find the elements which are common to both A and B. So here we can write A intersection B. There is no common element here. So A intersection B is the phi set, empty set. Now note, if A intersection B is an empty set, Reynolds set, then the two sets A and B are disjoint sets. Now let us discuss all these things, intersection of two sets through examples. Example, suppose we have given a set A containing the elements 3, 5, 7, 9, 11. B is a set of elements 7, 9, 11, 13. C is a set of elements 11, 13, 15. And D is a set containing elements 15, 17. Now, if you want to find A intersection B, so A intersection B will be, what are the elements common to set A and set B? See here, 3, 5, no, 7, 9, 7, 9 here, 11 here, 13. 13 not common. So, which elements are common? 7, 9, 11 present in set A and set B. So, A intersection B is the set of elements 7, 9, 11. Similarly, if you want to find B intersection C, B intersection C, find out which elements are common. 7 and 9 present in B but not in C. 11, 13. 11, 13 present in B, also in C. So, B intersection C is the set of elements 11, 13. If you want to find, say, A intersection C. A intersection C, similarly, which elements are common? 3, 5, here 3, 5 is not present, 7 not present, 9 not present, 11 present, here also 11 present. 13, 15 present in C but not in A. So, only one element, that is 11 present in both set A and C. So, A intersection C is the set containing element 11. Now, suppose we want to find the intersection of B and D. So, B intersection D. What is the intersection of B, D? Yes, 7, 9, 11, 13. Here 15, 17 means there is no elements which are common to both B and D. Therefore, our B intersection D is the empty set, that is phi set. So, in other words, here in note we have written, if intersection of two set is an empty set, then two sets are disjoint sets. Here B and D are disjoint sets. Similarly, you can find intersection A intersection C intersection D. A, C, D. Find out the elements which are common to A, C and D. Yes, here 3, 5, 7, 9, 11. Here 11 but here 15, 17. So, there are no elements common which common to A, C and D. So, A intersection C intersection D is the empty set. 5. Another intersection of A and D, you find out. If A intersection D, similarly you can tell there is no common element to both set A and D. So, A intersection D is also empty set. Okay. Now, properties of this intersection operation. As before we discussed the properties under union operation, similarly also here there are some properties under intersection operation. As before, A intersection B equal to B intersection A, and this is your commutative law. If we will find A intersection first B intersection C, then intersection with A, it is equal to, this is same as first you find A intersection B, then with intersection with set C. This both will be equal, and this is called associative law. Then A intersection phi, intersection of any set with empty set. So what can be the common element? This is phi. There is no element. That is equal to phi intersection A. This is called law of phi. And if you will find intersection of set A with our universal set, then the common will be set A, and this is equal to universal set U intersection A. This is called law of U. Then in case of union, we discussed one law, that is idempotent law. Here also in case of intersection, the same law here. A intersection A, that is A, it is known as idempotent law. And one more law here, that is based on both union and intersection, that is called distributive law. So A intersection B union C is equal to A intersection B union A intersection C. So means this intersection operation is distributed over union operation. Intersection operation is distributed over union operation, and this law is called distributive law. Which one is distributed? Intersection operation is distributed. See, in both cases intersection operation over union. So intersection is distributed over union. Therefore, this law is called distributive law. Let us prove this distributive law using Venn diagram. So, in this statement, our left side is A intersection B union C. So, left hand side is A intersection B union C. Let us draw Venn diagram for this. Universal set A, B, C. This is just set A, set B, set C. A intersection B union C, we will draw the Venn diagram. First B union C is inside the bracket. So let us draw the Venn diagram of B union C. As before, you know how to draw the Venn diagram of union of two sets. So this shaded portion is our B union C. Now A intersection of A and B union C. So this part is our B union C, the shaded portion. Now what is the intersection of this shaded portion with set A? So means this part. So this part is our A intersection B union C. So double shaded part is A intersection B union C. Now let us draw the Venn diagram of right hand side and see whether both are equal or not. Right hand side, for this we have to draw the Venn diagram. This is our universal set, set A, set B, set C. Now first A intersection B. A intersection B is this part. Then A intersection C. A intersection C. These are A set, C set. A intersection C is this part. Now what is the common of this A intersection B and A intersection B union A intersection C? So means all this portion and this portion. So see here what we find. This first left hand side double shaded part, here this shaded portion, both are same. So here that means right hand side the shaded portion is our A intersection B union A intersection C. Both are equal. Here double shaded portion is our left hand side and here this portion which we have shaded, that is your right hand side. Both are equal. So using Venn diagram also we can prove a statement is correct or not. After intersection operation, now we will discuss the operation difference. So difference of sets. Suppose we will take two sets, let A and B be two sets, then difference of these two sets can be denoted as, one can be written A minus B, or we can also write B minus A, and is defined as, if first we will find A minus B. So A minus B is also a set. Which elements it contains? It contains the elements X such that X belongs to A and X does not belong to B. So A minus B is also again a set of which elements? The elements which lie in A but not in B. That is your A minus B. And what is your B minus A? B minus A is the elements which lie in B but not in A. So this is again a set of elements X such that X belongs to B. X belongs to B. B minus A. So means the elements which are present in B not in A. And X does not belong to A.